Hi everybody. What we're going to do today is continue with Hess's law and just kind of work through another example. Because the Hess's law questions that you can end up dealing with can be more complicated than the one that we dealt with last time. So if you've not watched the last video, then I think it's definitely worth watching that first before we kind of start on this. So my title is Hess's law, but this is our second video on it. So the example that I'm going to start with is one where you're given a couple of equations in a question with delta H values, enthalpy change values for them, and you're asked to work out what the enthalpy change is for something else. So the ones we've got are as follows. We've got carbon in its solid state reacts with oxygen in a gas state and it becomes carbon monoxide in its gas state, and we're told that the delta H for this reaction, in fact let's keep it on the same page. We're told that the delta H here is equal to minus 216 kilojoules per mole. And we're given another equation. We're given carbon in its solid form burns completely in oxygen as a gas and becomes carbon dioxide as a gas, and we're given a delta H equal to minus 394 kilojoules per mole. So this is just information that you would be given in a question, or maybe you would be given a little bit of information to guide you to get this stuff out of a data book, perhaps. But the question is, what is enthalpy of combustion of carbon monoxide? And the enthalpy of combustion is the enthalpy that you get when 1 mole of a substance burns completely in oxygen. So the substance here is carbon monoxide. I'm going to burn it in oxygen, and if I do that, then if it burns fully, I'm going to get carbon dioxide. So this is going to be a gas, this is going to be a gas, this is a gas. Let's just quickly balance this. I've got the same number of C's on both sides, one there and one there, but my oxygen on the right hand side is 2, and the oxygen on the left hand side is 1, 2, 3. So I'm going to fix this by putting a half in there, and that means that on the left hand side I'm going to have, let's see, C is 1 and oxygen is 1. Half times 2 is 1, so there's 2 of them, and on this side C is 1 and my oxygens are 2. So everything's balancing now. But the delta H for this is unknown. We don't know what it is. Right, so we need to use the other equations in the question to somehow figure out what this delta H value is. So let's write out our kind of problem below again. So CO as a gas plus a half O2 as a gas goes to CO2 as a gas, and my delta H is unknown. Right, let's see what we've got in the question. Carbon monoxide does appear but it's all the way over here. And we've got a problem in that there's two of them there, whereas down here we've only got one of them. So we're going to have to somehow change the equation up here to kind of just start with carbon monoxide and become something else. Let's do that in a couple of steps. So let's probably easiest if we kind of just copy it and start in a kind of a blank bit of space. So let's copy that and move it all the way across. Slightly off screen there. Okay. So as I say, I need to get this this CO on this side over on the left hand side. I need the arrow pointing the other way, and I need to get rid of this 2 thing. So we're going to do that. We're going to do that in stages. First thing I'm going to do is I'm going to flip it round, and that's something that we saw how to do in the previous video. So I'm going to write 2CO as a gas goes to the 2C as a solid plus the O2 as a gas. And what happens when I do that is my delta H flips sign. My delta H equals 216. I multiply by -1 kilojoules per mole. Okay, so that's good. I've got 2CO on this side, but I want to have just one of the carbon monoxides on this side. So I'm going to do that, but by dividing everything by 2. You can think about this, if you like a maths equation. And if I do something to one side, I've got to do it to everything on the other side. Or you can think about it in other kinds of ways, but either way, we're somehow dividing everything by 2. So when I do that, I'm going to have a CO on this side, because 2 divided by 2 is 1. So if you like, I could kind of write in an imaginary 1 there, but we don't normally do that. Goes to 2CS divided by 2. 2 divided by 2 is 1, so I'm just going to get a CS. C is a solid, and if you wanted, you could write in an imaginary 1, but it's up to you. And then my O2, well, 1 divided by 2 is 1 split into 2 bits, so I just get a half. 1 over 2, O2 is a gas. And if I do all of that, then I also need to divide my 216 by 2. 216 divided by 2 kilojoules per mole. So let's just kind of write that out again. I've got CO as a gas. Let's get rid of that mark. Goes to C as a solid plus a half. O2 as a gas. And that 216, let's just do that. 216 divided by 2 is 108. So my delta H is equal to 108 kilojoules per mole. Great, and this thing now, this kind of manipulated thing, is something that I can use in my kind of going round the Hess's law circle. So let's do that. Let's try and remember that CO gas is going to make a C solid and a half O2. So here we go. CO as a gas is going to make a C solid plus a half O2, and that's a gas. And when it does that, the delta H is this 108 figure. So let's put that in. stick it in black. Delta H equals 108. Now the half O2, I don't have any kind of obvious thing that in the question. I mean, I suppose I could flip this round. I could somehow make O2, I could somehow turn this formula here, this second one, into a half O2. But I'm not going to do that. My instinct, because I've done this a number of times before, is just to move that half O2 up. So I'm not going to react it with anything. It's still hanging around, if you like. So I'm just going to put this a half O2 here. I could have done a lot of kind of manipulation if I wanted at that stage, but actually I know that that's a lot of complexity that I don't need to go through at this stage. And you'll develop those kinds of instincts as you practice your way through some of these questions. But it's stuff like that, it's stuff like getting your instinct for it, that actually, I suppose, makes these questions quite confusing. But let's go with this. Let's keep following our nose. This thing that I've written, actually, I can write as something much more simple. So I write the equal sign, which is just the same as is the same as. So these three things at the top here are the same as C as a solid plus, well, a half O2 and a half O2 is just the same as O2, or one of them. So I've got C as a solid plus O2 as a gas, and I somehow need to turn that into this CO2 here. Is there anything that can help me? Well, if I go back to my question, here it is. It's exactly the same. It's exactly what we want. We don't need to manipulate it at all. So C as a solid plus O2 as a gas goes to CO2 as a gas. Exactly what I've got here. C as a solid plus O2 as a gas goes to CO2 as a gas. And my delta H for this one from the question is just given to me as minus 394. So my delta H is equal to minus 394. So now we can just use our kind of Hess's law of facts to give us the answer. This thing here, this delta H, is the same as the delta H is going round a circle, so it's the same as this 108 plus this minus 394. So 108 plus minus 394, which is just the same as 108 minus 394, which is, let's go to our calculator again. 108 minus 394 is minus 286. So I get minus 286, and I should write in my units, kilojoules per mole. And that is our final answer.